take a look at an example. A sphere with radius a centered at the origin is expressed in rectangular coordinates as x squared plus y squared plus z squared is a squared. In cylindrical coordinates, we can write this as r squared plus z squared equals a squared, because this right here is in fact r squared. And you know, cylindrical coordinates are nothing more than polar coordinates, where we throw in a z basically. So the surface I can represent in polar coordinates as z equals a squared minus r squared, which is the top half of a sphere. So the total volume I can write as v equals twice the integral over the appropriate region of, and this is supposed to be a negative right there, make sure you fix that, of a squared minus r squared dA. So let's go ahead and do this integral. So this volume will be equal to twice the integral. Well, remember, this is the top half of a sphere, so I'm going to go all the way around. So from 0 to 2 pi. And then my radius, it will be going from 0 to a of the square root of a squared minus r squared, r dr d theta. And I'll integrate this like you normally would. So I would let u equal a squared minus r squared. That gives me negative du over 2 equals r dr. So obviously these 2's are going to end up canceling. So this is going to give me the negative of the integral u to the 1/2 du, which is going to be 2u to the 3/2 over 3. But I need to get back to my a's and r's, so that's going to be 2/3 times a squared minus r squared to the 3/2. That would be evaluated from 0 to a. When I lost my negative. I gotta keep track of this guy. Put that negative in there. So when well, I'll go ahead and write the whole thing out. But when r equals a, this will be 0. So this is a negative 2/3 times, this first one is going to be 0, minus, when a is 0, I get a cubed. So that's going to give me 2/3 a cubed. So now I'll go ahead and complete the integral. So I need to go from 0 to 2 pi of 2/3 a cubed d theta. So that's just simply going to be 2/3 a cubed theta evaluated from 0 to 2 pi. So when theta is 2 pi, I get 4/3 pi a cubed. When theta is 0, I get 0. But remember, this a was really our radius, because we're that top half of the sphere, so we're going out from 0 out to a. So really, I'm going to write this as 4/3 pi r cubed, which hopefully you recognize as the volume of a sphere. That's in the cover of almost every calculus book. And you may have actually integrated this or use a different technique back in Calc 2, volumes of revolution, that sort of a thing, to also come up with this, this equation, this formula for the volume of a sphere.